Okay, so this is lab number 5. Starting over again here. So, we have our paper laid out. We've got our pointer. We need to make our TCP. So let's start going through that. So, program data, tool data, show data. I started making this and canceled it, so we'll start over again here. I'm going to make a new. It is called T. Pointer 1. Pointer 1. We are going to define that pointer. So we need to do 3 or 4 positions. So my first position over here. I'm going to do this all with a linear. Between linear and reorient. So let's try to get this going here. It is easier to move the pointer than to move the robot, so I try to get this to the right height and then actually just move that pointer in place. I'm not going to worry too much about my accuracy for this. I'm just going to do this quickly. So there's point number 1. So we say point 1, modify position. I'm going to teach point number 2, so I'm going to switch to reorient. Spin this out of the way. Move back to linear. And I think that is pretty close there. So that is my point number 2. So I touch that, I modify position for point 2. I'm going to point number 3. So I'm going back to reorient. I think that is good for point number 3. That's my point 3. And point 4. Again, reorient. Linear. call that point number 4. Now, I went these really quickly, so we'll see how accurate I got it. You could probably do this more accurately, taking your time a little bit more, but that is my 4 points. I'm going to hit OK. It will calculate, and my max error came out nicely. I have 0.77 as my max error, so that is acceptable. I will now say OK. Remember to write down your max error before you hit OK because you can't see it afterwards. Now I'm going to double click here because I need to set my center of gravity, and you'll notice 1 millimeter in the X, a little under 1 in the Y. We'd expect those to be around 0. 197 in the Z. We'd expect that to be around 200 or so. So that all seems reasonable. My mass, the default value comes up as -1. We're going to change that to 1. And the center of gravity, that first array there is grayed out. We're going to select the Z value of 10 and say OK, and that is my pointer completed. Now let's go to jogging. I'm going to select now tool pointer and do a reorient here, and what I should see when I do a reorient now, I should remain stuck tip to tip because my new center point is on the end of the pencil. So that is my point of rotation now, is the end of the pencil. If I was to change this back to tool 0 and reorient, you'll see now my center of rotation is actually the right in there at the end of the robot, because that is where tool 0 is centered at. And that point remains fixed in space. So that is the difference. So I shifted that tool center point from the end of the robot to the end of the pencil effectively by doing this. So that is the exercise of doing TCP. Okay, now that I've done a TCP, I want to get into the lab, so I'm done with the pointer. I'll move that out of the way. And I want to move over here. So the first thing I want to do is teach a home position. So home position should be above the object we're working with. So I want to do a home position somewhere up here. I want to be perpendicular to the page. So let's get that. So when I teach my home position, I'm going to teach this in tool 0. And it's important that I do this. I'm going to be in tool 0 because my point is going to be done in tool 0. So I'm going to show you a couple tricks here. First thing I'm going to do is use a function that's called align. So this is under the jogging menu. This here, which is called align, I'm going to use this. What this will do, it will align your tool to make it completely perpendicular to your surface. So the way that I do this, I basically hold down that button that says Start Align. So I'm going to hold down that button, and you'll see what happens here as I hold it down. So I enable, hold down the Align button, and you'll see this will turn this thing over so it is perfectly straight up and down, which is pretty effective to do. So very good. The other thing I'm going to do, I'm just going to reorient this, turn it around. I'm going to spin this around so it is in the same orientation as my paper. I'm going to try to square it to my paper. just by eyeballing it. So just like that. Okay. So I'm still working in tool 0. I'm only ever going to use reorient and linear from this point on. I'm never going to use the 1, 2, 3, 4, 5, 6 joint jogging. We don't use that when we are teaching, typically. Alright, so let's start making some stuff here. The first thing we're going to do, it doesn't call this out specifically in the lab, but I'm going to teach a home position, and I'm going to teach that in the main routine. I'm going to go to Program Editor, in the main routine, and I am going to jog myself over here. I was going to say that's my home position right there. I've got a good position. So let's teach this as home position. Remember, home position we're going to teach as T0. And important to notice that I was in T0 when I'm teaching this position. That is the tool that I have active right now. So I'm going to say add instruction, move J, and I'm going to say edit, change selected to point. I'm going to make a new point. I'm going to call this P home. Now I'm doing this lab for the second time. What you want to do is basically create P home. My problem is that P home already exists. So if you already have all these points, if you have a point that already exists, in my case these are already in here, so what I'm going to do, I'm just going to select P home, but my point is different than what's already in here. So I'm just going to do this. I'm going to select that point. It's P home, and I'm just going to say modify position to ensure that what I am using is where I'm currently at right now. Alright, so that is my home position. Notice that it is in tool 0. That's what we want. So that's my home position. I'm now going to create a new routine. So under routines, file, new routine. This is called demo outline. Let's start teaching in demo outline. I spelled demo outline wrong. That's okay. So I'm going to start off by doing a little pounce position and then the start position. Now what I'm going to do, I'm going to make sure that everything I teach from this point on is going to be done in T pointer. And now here's the trick to this lab. I am going to operate in the tool frame coordinate system. So I select tool here. So all my jogging now is going to be relative to my tool. And this is going to become very important. And you're not really going to notice it much when you're jogging when we were in the base coordinate system. Base coordinate system was basically X is positive here, Z is positive this way, Y is positive this way. Tool coordinate system is basically oriented to however your tool is. So in my case, it is like this. Z is down, Y is now sideways like this, perpendicular to the tool, and X is away from me in the positive direction. Okay, I'm just going to put this on here as a reference. You can kind of see that up there. So that's X, downwards is Z, Y is to the side. That is going to be my coordinate system I'm working in when I'm in tool. And this is going to make it very easy to teach this. And I'll show you why that is in just a minute here. So let's jog ourselves over to the paper. Now you'll notice when I start jogging, if I pull the stick towards myself, that's positive X, and it comes basically in the X direction. Y is side to side like that, and Z is downwards. So I'm going to make a pounce position above start. So we'll do that. And let's teach this as our first position here. This is our outline, so add position. We're going to do a J move to here. And this will actually be, edit this. So I could either say change selected, or I can just double click on that guy. And then I want to put in this I actually call this, and again, I have all these positions already created. If you didn't have these created already, you just say new. But we're going to call this start pounce, or whatever you want to call it. And because I'm creating this new, I'm going to say modify position. Alright, so start pounce. I'm going to do a zone of 50. I'm okay with that. My next thing I want to do, I'm going to move downwards. So straight down to 25 millimeters above the page. Let's say right there. I'm going to do that as a J move as well. Add instruction. Move J. It's going to be below. And this position I'm going to call P start. Modify position. Modify. This one, I'm going to actually change this. Everything I'm going to do inside here is now going to be a fine move. So that's a fine. And notice that I am doing everything in here is under the T-pointer tool. Alright, so now my procedure is basically move to the next point, add the next move. So, in linear, I move over to here. That is P1. Add instruction. Move linear. P1, okay. Modify position, modify. Fine move, velocity 1000. That's good. My next move is a circular going through P2 to get to P3. So move C. Notice it just throws in 2 garbage points there. So we are going to select this point. This is going to be P2. This next one over here is P3. Oh, let's modify that first. The student's trying to talk to me while I'm doing this. That looks pretty good. This is P3. And modify. And that is a fine. You know what? We'll try this. We'll do a Z0 on here. I think it looks nicer on the. We round these circular moves. So that's that. Now let's go back to I'm just going to add in a call here. Call the demo outline. Below, let's debug this. It's always good to just try debugging as you go. Add a couple points, try debugging it, see if everything is okay. So here is pounce, start, P1, circle, back to home. And come in, pounce, start, circle, back to home. So that's what we have so far. So this is basically our process, and we will carry on from there. Okay, so here comes the magical part of this lab. So let's do the incline. So how do we handle the incline? So first of all, let's teach this point, and then into this point, and then this curve right here. So we want to teach this point here. So I'm going to call this point 11. I'm going to teach another point right here, right at the bend. And then point 13, 14, and 15. So let's do those. So I'm going to get my pendant here. And let's jog this over. We'll just add it down to the bottom here, so I'm still jogging in tool. So we're going to call this point 11 here. So let's do a linear to point 11. Okay. Modify position. That's still in fine, that's good. All right, now here comes the cool part here. So let's go over to point number 12. It's going to be right there. Now we're going to start to bend. So let's reorient. And start to reorient in this direction. Back away here. reorient. And I'm going to get about halfway up that incline. So let's pick a point about halfway there. Like the angle is about halfway. Bring it in close. Notice when I jog in the Z direction, because I'm in tool right now, jogging in the Z direction is just going in the direction of the pencil. So I'm going to call that point 12. So we're going to do a linear to point 12. So notice that I'm like that right now. I'm going to do and now what I want to do is I want to roll this all the way over so that I am perpendicular to that inclined surface. How can I tell I'm perpendicular? Because I'm just eyeballing it. But I think that looks pretty good. I'm just going to verify by holding up a piece of paper. I want to get about 90 degrees. That's a little bit too much. There, that's about 90 degrees. So that is about 90 degrees now to my inclined surface. So now I'm going to go back to linear. I'll go back to linear. Notice that I'm still in, oops. Notice that I'm still in tool. Now the beauty of this now is that when I jog in tool, in linear, that's my X. Sorry, that's my Y direction. My X is now parallel to this. Makes it very easy for me to work. And my Z is in and out from that inclined surface. So remember, the frame is basically the frame of the tool, not the world system. So it makes it very easy for me to trace shapes that are on that inclined surface. So my next point that I need is P13. Which is going to be here. So I'm going to do a move C. So I'm doing a move L first to 13. A move L to 13. And then a move C to 14 and 15. So 14 is right there. And 15. right about here. But this is really the great thing about working in the tool frame, is that you can easily work on any kind of surface like this. So let's now try running this. So I'm going to debug PP to main and see what happens. So I go from home position. I only do the first couple points and then I skip out, but first couple points and then jump all the way over to there. And you'll see it roll right over, go up, and then work on that inclined surface. Okay, so that is working with the tool frame and what we can do in this lab. Okay, so this is the completed version of lab number 5. You can see I have the paper here. And what I've done, I've labeled all of my points on here to try to make it easier for me when I'm programming, so I know what's what when I'm going through and programming. And you can see this is on the angle like that. You can set this up on an angle however you like. I have this as a home position with tool 0, and then a call to the demo outline. My code for this is quite extensive. There's quite a lot of points here. I'm going from I go to a pounds position and then go for my start, and then all the points are named sequentially like that to match up with my paper. There's a combination of pretty much everything's a linear or a circular move. I use fine points. I use the Z5s and the Z10s according to the lab, how they're called out. But let's try running this and seeing what it looks like. So PP to main. So when I taught this, I taught it all in tool, so my tool pointer, and I was using it in the tool coordinate system as well. So when I taught these points here, I could very easily navigate up the inclined surface. Made it very easy to trace that. And that is it.